All right, so in this video, we are going to be talking about what does it mean to be rational, what does a rational parent function look like. So the first thing is I want you to pause the video and I want you to simplify all of these warm-up questions. Please leave it in simplified fraction form. And pause the video and go ahead and simplify these warm-up questions. Okay, so for the first one, we can technically divide top and bottom by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. So if I actually divide them, I get 4. Where this one, when I divide by 3, I get 1 over 4. Okay, if I type in 0 divided by 3 in my calculator, I would get 0. Because if 0 is on top, it's okay. If it's on the bottom, we would get undefined. Okay, or knocked out, doesn't work. Okay, so we're going to kind of look at how do rational functions deal with those undefined. What do they look like on a graph? Okay, so graphing rational functions, compare rational functions in multiple representations. We're going to compare their basic graphs, and then we'll be able to lead into when we kind of move it around left, right, up, down. What does that do? We're going to talk about asymptotes and poles. Okay, so what is a reciprocal? So go ahead and pause the video and try to think about these couple comments here. A reciprocal is kind of like a flip function. So if I had 2, his reciprocal would be 1 over 2. If I had 3 over 2, his reciprocal would be 2/3. What is a rational number? So if you Google rational number and examples, what is it? Okay, it is negatives to positives. It is whole numbers to decimals. So 0.5, 0.7, 0.67923, okay, -4, 7. Okay, can I divide by 0? I cannot divide by 0. It would give me an error in my calculator. All right, so throughout this course, you have studied many connections between polynomial functions and real numbers and imaginaries. It follows then that polynomial functions also have reciprocals. So we'll flip. Is a reciprocal also a polynomial? Is it a function? How does 1 over f of x compare to the original f of x? Okay, so what we're going to do is this first set in all of these is the graph of the line. So if that set kind of confuses you, what we're going to do is kind of ignore that middle. Ignore the middle, ignore the middle. And I want you guys to plug in all of these x values into the equation to find the y values. So for example, the first one, if I plug -6 in, I'd be doing 1 divided by -6 to plug into this. And then when we're graphing, it's a lot easier to use decimals. So if I do 1 divided by 6, it is -0.167. Okay, so I want you guys to pause the video and I want you guys to fill out this table and actually practice typing it into your calculator, because some of the key is, can I just type this in? Okay, so when we get to the fractions here, you have to be careful that when you do 1 divided by -1/2, you have to put this in parentheses. Otherwise, it's going to be 1 divided by 1 divided by 2, which is not the same thing. Okay, so when you're doing your fractions, please make sure when you do your fractions, you put it in parentheses. All right, so if I keep going, this is -0.2. This is -0.25. This is -0.33, -0.5, -1. Okay, so now if I graph them, this is the x coordinate, this is the y. So I'm going to do -6 and really close to that. Then -5 is -0.2, so a little bit further away. -4, -0.25, a little further away. So all of them should be getting closer and closer, where it's going to get closer and closer to 0 on this side. So there's actually an asymptote that's going to occur at the top there. So you're going to get closer and closer to the x-axis. Okay, this should be the same thing, but all positive. So 1, 0.5, 0.33, 0.25, 0.2, 0.167. Okay, so now if I graph it, 1, 1, 1 or 2 and half, and then we're going to get closer and closer to the x-axis on this side. All right, well, I got to figure out what are all these values in between here, so that's what my next box is for. So 1 divided by 1, this is negative 1. 1 divided by negative 1/2 in parentheses is negative 2. Okay, this should get me negative 10, negative 100. 1 divided by 0 is undefined. We will not be able to graph it because there's an asymptote there. These are all just going to be the positive values of what we just did. So negative 1, we already have our dot. Negative 1/2, negative 2. Okay, negative 10, so really close to 0, negative 10. So we have our other asymptote on this axis. So it shouldn't actually cross there. Okay, and then we're going to have a familiar one. We can't do the 100, so 1/10, 10, so really close. And then 1/2 to 2. So it's going to look like that. So we're actually going to have two asymptotes that are occurring here, which we'll talk about. So there's an asymptote here and an asymptote here that we get really, really close to, but we do not cross. Okay, so if we go into this part here, it says describe the graph g of x, how is it similar to the graph of other functions? So we should have paused the video. What other functions have we talked about? We've talked about lines, we've talked about quadratics, we've talked about exponentials. So what are they the same as and what are they different as? So go ahead and pause the video and write some similarities and some differences. Okay, so some similarities. Passes the vertical line test. Okay, they look like two exponentials. They both curve like a quadratic. Okay, some differences. They're not straight like a line. There's two lines that are separate from each other. Okay, so the next question says describe the end behavior. So end behavior is the x values. And it's what's happening on the end. So on the left side and the right side of my graph. So left side and right side. So what are the x values doing on the left side of my graph? If they keep going this way, they keep going to negative infinity. Okay, what are they doing on the right side of my graph? They keep going this way. So positive infinity. Okay, so describe g of x as x approaches 0 from the left. Okay, and the output behavior of the function. We're going to go ahead and skip D and E here. So it says, does the graph ever intersect the horizontal line y equals 0? So if I go back to my picture, does it ever, horizontals left to right, does it ever intersect this line? It does not. Okay, so here's my original equation, g of x. G of x also means y. So it's saying, well, when y is equal to 0, why don't we cross there? So if I actually plug 0 in for that y, I have this. Ooh, how do I get rid of the fraction? To get rid of that fraction, I need to multiply that x. So it cancels on this side. So I've got 1 left. 0 times x is 0. 1 will never equal 0. That is why there is an asymptote there. Because I don't actually have x equals something or y equals something. Okay, so does the graph ever cross the vertical line? So, okay, we have our vertical line here at x equals 0. It does not cross it. So if I go back, we're going to find mathematically. So here is my original equation again. So this is saying, well, what happens when I plug 0 in for x this time? Okay, can I do 1 divided by 0? No, it's undefined. Can't have 0 on the bottom of a fraction. Okay, so that is the reason why that vertical asymptote is appearing. So it says describe the domain and range. So if I look back at this graph, my domain is on my x values. So if this goes forever to the left, I'm covering all the x values to the left. I'm also covering all the x values to the right. But the problem is I can't cover this asymptote. I'm not crossing at the x value of 0. Okay, so if I'm writing it, there's two different ways you could write it. I could say I'm going from negative infinity, which I cannot hit, to 0. I cannot hit 0 because if I hit 0, it's going to be undefined. I could then start back up at that 0 and go to infinity. Okay, the shortcut of writing this, everything less than 0 and everything greater than 0. So if you literally took the infinity signs off and made sure x is on the left-hand side, that's what it would look like. So now if I do my range, I hit everything from the bottom and everything in the top. But again, I can't hit 0. So when I go back here for my range, I'm doing the exact same thing. I can't hit 0. I start back up at 0, and I want everything bigger than it. Okay, so the shortcut writing is everything less than 0 and everything bigger than 0. Make sure you're using Y values for the range. Okay, so different notations. I want you to go ahead and read through page 134 and 135 on your own. It's going to talk about vertical asymptotes, horizontal asymptotes, and then the next page that you're going to do is this one here, the activity 1.2. So go ahead and pause the video, read through what it talks about for vertical asymptotes and horizontal asymptotes. All right, so in 1.2, we're going to discover, okay, well, what if it is, instead of 1 over x, what if it is 1 over x squared? So I want you guys to go ahead and flip to page 138. And we are going to fill out that table. So I want you to pause the video. When you go to fill out the table, because we're doing a squared, when you type a number in, so let's say my x value is -2, you have to put it in parentheses and the squared on the outside of the parentheses. Otherwise, you're going to get negative answers. All of these y values, when we plug it in for the x squared function, should be positive. Okay, so go ahead and find all of your boxes, pause the video, and then I want you to graph all of them. So if you want to play the video, check to make sure your x's and y's are correct, and then graph it, you can do that, but go ahead and pause the video. Okay, so this should look like this. Easier thing to do when you graph it is actually find the decimals. So find the decimal of 1 over 25 if you did it. Find the decimal of 1 over 16, so that when you go to graph it, it's a little bit better. Okay, so when we graph, again, you're going to ignore the center one because that's the original. And then you're going to graph the point -5 with his decimal, -4 with his decimal, -3 with his decimal, -2 with his decimal. Okay, so here's your OG, so your g of x. And then go ahead and see what does the function look like when we do his reciprocal. So pause the video, graph those points. Okay, so what it should look like is this. So this is my r of x. Okay, so the next question is going to be state the domain and range of this. Let me see if I have a picture on this one. I did perfect. So it says domain and range. So remember, domain is all of the x values I want to be. So I'm looking at my purple graph. This goes forever to the left. He stops here. He starts back up and goes forever to the right. So I can't be 0 again. So I'm going to do negative infinity to 0 or 0 to positive infinity, or I could say everything less than 0 and everything greater than 0. All right. My range is a little different. Reading it from bottom to top, the first purple value I see is here, and then it goes all up here. Okay, so I'm going from 0 to infinity this time because I don't have anything down here. All right, so I could represent it like this, or I could say everything greater than 0. One of those two options. Still can't be 0 because it's an asymptote, but I also just want everything bigger than that. Okay, and behavior, remember, deals with x values. So what is happening on the left side of my graph? What is happening on the right side of my graph? So I want you to go ahead and fill that in. So pause the video, state what's happening to those x values on the right, what's happening to those x values on the left, and then we will talk about their asymptotes. Right, so the right side of my, or I guess left side of my first. So left side of my graph is going to more negative infinity. The right side of my graph, all those x values are going to positive infinity. All right, so then it says state the vertical and horizontal asymptote. So remember, horizontal is like the horizon. So we're talking about this one here. Okay, that one we have the option of x equals or y equals. Horizontal lines are y equals because they have a zero slope. And it's sitting at the y value of 0. Okay. Now I've got my vertical one. Verticals are x equals, and he is sitting at the x value of 0. Okay. He is an undefined slope, which is why his x equals and not y equals. Okay, and then the last question here is talking about using graphing technology to explore key characteristics of the reciprocals of all power functions. So when they're even, so 1 over x squared, or when they're odd, 1 over x cubed. So my even functions, the reciprocal of all even power functions, will look relatively similar to each other. The graph becomes steeper as the exponent becomes greater. The domain will always be all real numbers excluding 0. The range will always be all real numbers greater than 0 because y can't be 0 or a negative value. The asymptotes will still be x equals 0 and y equals 0. For the odd functions, the reciprocal of all odd powered functions will look relatively similar to each other. The graph becomes steeper as the exponent becomes greater. The domain and range will always be all real numbers excluding 0. The asymptotes will still be x equals 0 and y equals 0.